He designs and demonstrates end-to-end AI pipelines covering data preparation, model development, deployment, and validation on edge and cloud platform. He is an AWS certified machine learning associate actively working on cloud-based ML solutions using Amazon Web Services. He collaborates with academicians, research, and scientists to develop proof of concepts and applied AI solutions. He serves as curriculum advisor and board of studies member, contributing to industry-aligned curricula in AI, generative AI, AI on edge, and applied machine learning. So I wish you all a very productive and useful session. Please, sir, you may start the session.
Thank you, sir.
Welcome, sir.
Uh, Welcome, dear participants. Let me share my screen. I hope, sir, the screen is visible. Hello, can I get an acknowledgement like if screen is visible?
Yes, yes,
Uh,
screen visible. Yes.
no,
Yeah,
no. Yes, yes.
yeah. Okay. So this is the basic agenda. We'll be starting with solar PV modeling. I think most of the speakers have already covered the fundamentals, but still I will try to share a few things with respect to solar panel operation uh, with respect from MathWorks side. We will look at some PV curve, MPPT concepts. I have taken few hands-on demos with me. Um, there are 2 and 3 demos. Let's see how the time goes. And whatever I'm taking hands-on sessions today in my talk, the rest of the things will be continued in tomorrow's session by my colleague Ankit. Okay, moving ahead, I'll just like to take few minutes to let you know like where we use MATLAB and Simulink. These are our key customers. As you can see, we support customers applications right from aerospace, defense, automotive, renewable energy, semiconductors, and all other sort of things. A quick yes or no will really help me to understand like have you used MATLAB earlier, something like that. So let me turn on the chat window and let me first understand. Have you used MATLAB Simulink like with respect to this? So basically you'll understand like should I start with the hands-on part or I need to cover some fundamentals of Simulink. You can enter 1, 2, 3. Okay. Okay, so I'm getting 3. This is the first time you are hearing about MATLAB and Simulink. Okay, yes or no? Yes, fine, fine. So I can say I have a mixed audience, so I won't go into detail, but I'll give you an overview of Simulink, not of MATLAB, because we'll be designing our demos of creating models in Simulink. Okay, very quickly, what is the role of MATLAB in engineering? So if we talk about MATLAB, MATLAB and Simulink are the 2 flagship products of MathWorks. MATLAB is basically an environment for technical computing. And if you talk about Simulink, Simulink is a block diagram environment used for creating models. It supports model-based design for multi-domain applications. We can simulate a model and we can also generate the code with the help of coder products over here into C, C++, and HDL code. Moving ahead, if we talk about MATLAB in detail, MATLAB has been specifically designed for algorithm development. You can go for data analysis, data visualization, and there are a lot of things that we can do with MATLAB. If we talk about Simulink, Simulink supports block diagram environment. It has Simulink library browser. In Simulink library browser, we'll get different blocks with respect to different toolbox. And as per our applications, we can go to Simulink library. Under Simulink, we can drag and drop those blocks together and we can build up a model. And we will be also be able to do this for different applications like embed system, control, signal, communication, and so on. Moving ahead, if we talk about product map, we have over here MATLAB and Simulink as the two flagship products. And depending upon our applications, we may try to add on the different toolboxes. So these are only few toolboxes that I've mentioned over here. Let us go to the product page. So if I go to my product page, this is MATLAB product page. Let me copy the link and share the same with you. So if I look at my product page, you will find out over here we have MATLAB product family and Simulink product family. Instead of this, we'll talk about the application wise. Now, when we talk about building an application, it is really important for us to choose tools initially. If you talk about this, we have different applications right from signal processing, image control, wireless, test and measurement, computational thinking, and so on. And if I go to this Simulink over here, you may find out I have event based modeling, I have physical modeling. So if I want to design batteries, I will use tool Simulink, Simscape, and Simscape battery. Today we'll be using some tools. So I'll be using Simulink, MATLAB, Simulink. I'll be using Simscape. I'll be using Simscape electrical, right? And if I can show you, like, let's say, like, we can go to control system and we can I can show you some PID tuner if required. Basically, if I want to design some logic, then I will go to state flow. So these are the fundamental things that we should be aware about. If you talk about code generation over here, we have different coder products, Simulink coder, embedded coder. You can also see Oriel HDL coder and GPU coder. So what we can do is we can use MATLAB Simulink environment. We can build up a model over here, and then we can use the coder product to generate the C code. Later on, this code can be flashed into the hardware for our requirement. Fine. Before we go ahead, let's try to understand what do you mean by model-based design. Model-based design is the current skill requirement as per the industry norms. And you could see why industry follows this. Let's try to understand this into certain steps. We do some research, we gather requirements. This is our first step. We link the design and the required parameters. In the second phase, when we want to design an application, for example, let us consider our photovoltaic application or a solar panel or array. It will require some motor to control the orientation of solar panels. We may need to write some embed algorithm. For example, I want to design a maximum point tracker, MPPT, maximum point power tracker over here. I may need to design a charger or a buck converter or an inverter over here. Okay. And then it may have a mechanical components. Now this requires a tool which should support multi-domain functionality. Next, you can see, so from step 1, we move to step 2. From step 2, we can move to step 3. If we are okay with understanding like how to design the system, simulate the system, and if we are okay with all the design aspects, we can go and simulate it. Once simulate, we can go ahead and we can generate the code. So depending upon the target hardware, we can generate the code, and later on we'll try to integrate them together. Now, what model based design says that we should simulate our design earlier rather than directly moving to hardware, okay, so as to detect earlier in the testing phase itself. That's the reason we have over here this back propagation arrows. So model based design is a concept not from MathWorks point of view, but it's a general concept that is being followed in industry by different when people use different tools. Moving ahead, let us try to create an account. It will hardly take you 2 to 3 minutes because I'll be also sharing some link with you, wherein you will get access to the different modular curriculums that have been designed by MathWorks team. So for that, let me understand. Okay, for that, what I can do is this is the link. Requesting you all to please use this link. So if I copy this link over here, press enter, it will take me to the MathWorks account. So I'll just show you what exactly you can do. So when I'm logging it, I'm getting an access to my MATLAB license. What you can do is I'll show you this in incognito window. Use the link that I have shared with you. Click on this link. It's asking you sign into your MathWorks account if you have one. If you do not have that, it's fine. You can click on create one, start entering your details. It's okay if you have your university account or institute account. If not, you can use this kind of account that I have, and then you can access the trial license. Right? So the trial license is accessible for 30 days and you get access to all the different toolboxes over here. Fine? Are you able to access this? Are you able to access this? If yes, if yes, then I will share the modular curriculum link with you. Okay, thank you. Thank you, sir. Thank you, ma'am. So this is the link of modular curriculum courses that have been designed by MathWorks. And there are many institutes, they have adopted this particular curriculum. And whenever there is a feedback, they convey this feedback to us. So what I'm doing is, you have a course over here known as renewable microgrid, if you can see over here. And it has different modules: solar, wind, in AC machines, microgrid management, EMS, and all that. So what I'm doing is I am sharing this particular link with you. So let me create a link, copy link. I have shared this link with you. Now, if you go to your Windows browser, any browser, and if you click on this link, it will take you to a folder through the web interface, and it will show you the files that I have shared with you. Now you can see I'm not logged in right now on the right hand side, but I want to use this examples. So I'll be taking few of the examples. Okay. The next part will be covered by Ankit. So what you can do is you can click on add to my files and click on copy folder. And again, it will ask you, okay, do you have an account or you don't have an account? And then you will be able to use this particular files in your web browser itself. Those who have license, you can go to this link, and then there is an option over here for download. So I can click on this link, renewable thing, and either right click, download, and you will get all the files. So I'm not sharing files only for solar PV, but for entire renewable microgrid. If any one of you is interested in accessing all this curriculum folder, please let me know. You can share the email ID to the organizers. I will share this particular link with them. Okay, let's move ahead. I think most of the things might have been covered by other speakers, so I will try to restrict myself and I'll focus most of the things on with respect to the hands-on part. Okay, so let's talk about introduction to solar energy modeling. We have been using solar photovoltaic system, which convert incident solar irradiance directly into the electrical energy. If you talk about performance, the performance mainly depend upon the environmental conditions, that may be irradiance, temperature, and shading. I'll be taking few examples where I'm taking parameters irradiance and temperature. The shading example, I think Ankit will cover. If it doesn't cover, I am going to share you a link where you can understand how the shading part has been implemented. We will be using MATLAB, Simulink, Simscape Electrical, Stateflow, and other tools to provide a model-based design workflow. We have already gone through what is model-based design workflow. So it will help us first to analyze the behavior of photovoltaic system, then validate the parameters, evaluate hybrid configurations. Okay. And then what we can do is we can go for further advanced examples where we can go ahead with accurate modeling with respect to optimization, system sizing, reliability, and real-time implementation. Let's move ahead. So before we go to hands-on, we should consider that when we talk about renewal over here, renewable energy, a renewable energy integrated system comprises of various technologies. So here you can see PVRE, windmill, hydro kind of thing. Okay. And then what we can do is like in this particular hands-on exercise, we will try to use different renewable energy components and we can later on model them and use in the electric grid. So this is with respect to the modular course that I have shared with you. Let's move ahead and start with our first example. This is my first example. And before I move ahead, like I attended the earlier speaker sessions a few minutes and he was talking about this PN junction. So I don't need to explain this really, but I'll talk about what is photoelectric principle. I think this is already covered. What I'm interested in is understanding what is power voltage curve, PV curve. So in this diagram over here, you can find out I have output voltage versus output power. I have a legend over here and every color over here represent a curve with different temperature. Okay. So what is power voltage curve? It represents how output voltage varies with voltage for solar cell or PV module. It is essential for inverter design and MPPT, and it is mostly influenced by irradiance, sunlight, and the cell temperature. Moving ahead, let's go to our first demo. I'll be sharing this slide with you. Okay. And over here, I've included the hyperlink. So nothing to worry about. I'll also tell you how to access this particular examples. Before this example, if you have already access to the modular curriculum over here, if you have downloaded this, let me know if you were able to download this probably at the end of the session. So what I've done is I have already downloaded this and I will show you something about MATLAB and Simulink before actually I go to this particular exercise and the demo. So we have, this is MATLAB version 2025A. What you're looking right now is the MATLAB desktop layout. I have three tabs over here: home, plots, and apps. This is home tab. In the home tab, I have an option for layout. You can change the layout over here, 2 column or 3 column. So I have 3 column layouts. On the left hand side, I have files. So all my demos that I'll be using today, you can find out all those demos on the left hand side. So I've created a folder on the desktop and I've saved all the demos over here. You can see the slide which I'm using right now, it's over here. Okay. And the folder renewable grid is over here. Fine. So the central part is known as command window, and on the right hand side I have a workspace variable. Before I get started, I will set the layout to two column. I will type the command VR. The VR command helps me to understand what are the different tools that are being installed over here. So you can find out I have MATLAB, I have Simulink. Okay. All others are arranged in alphabetical order. So I was talking about SimScape, right? So if you scroll down, we have different toolboxes over here. I have SimScape. I have SimScape Electrical. I'll be requiring that. Okay. SimScape Fluid or SimScape, what you can say, we can use SimScape Fluid. I'll show you certain blocks, how they can be used for thermal management. Okay. In addition to this, if we want to go for optimization kind of thing, I have Simulink Design Optimization over here. Okay. Scrolling down, I have Stateflow for logic implementation. I'll check if Ankit will like to cover MPPT algorithm development in the second session. And all other toolboxes are present over here. Let us type CLC. I have checked, I have got all the toolboxes. So this is my basic MATLAB environment. Since we are going to use both MATLAB and Simulink and running certain scripts from MATLAB, let's try to launch this Simulink. You can launch this Simulink by typing Simulink in the command window, press enter, or there is one more option over here, home. So I'll home, and I have a different tab over here for Simulink. This is one way, like I can type the command, press enter, the Simulink window opens up, or you can go to home, navigate to Simulink tab, and the Simulink tab launches. So this is Simulink startup page. So those who are first time users of Simulink, we can understand there are different options over here, starting from blank model, blank subsystem, blank library, and so on. For a first time user, we should always start with a blank model. And if you are a user and already being using what you can say Simulink and Simscape earlier, there are different templates. So if you scroll down, you'll find out over here template under Simscape, and you can see all these are different templates which are available. So generic Simscape, Simscape battery, Simscape electrical, Simscape gas. These are the different templates. Now, what does templates talk about? These templates talk about some fundamental blocks that we may require when we go ahead and build our model. For example, let me show you both specialized power system and generic Simscape. So if I click on generic Simscape, I'll be using this particular template. And by default, you'll find out that I have some components over here, scope, solver, and so on. Right? Okay. Don't worry. Then I can go to specialized power system, and I can find out over here there are additional blocks which we were not able to see earlier. So what is advice? Should we always start with a blank model? You can see now this is for specialist power system. I have more blocks over here. Most of the people have been already using this particular Simscape specialized power system in their academics and research work. So this is how you can access it. But what I'm going to do is I will try to show you how we can build up a very small model. Okay. So I can go to simulation, click on new, and I can click on blank model over here. So let's click on blank model. right? You have got the model. This is the blank canvas. Here I want to build up a model. How I should start? I do not see any blocks over here in my canvas. So you have to click on library browser. This is my library browser. And I have an option over here to launch the library browser in a standalone mode. So that's what I'm going to do. Let's click on this launching the library in a standalone mode. So you can see I've been able to launch this. Now what is happening is, like, most of us have been using Simulink, but we've been using only few part. That is Simulink, commonly used block, logic, labels, syncs, sources, routing, and other sort of things. But if you scroll down, we should be able to see different toolboxes. You can put in chat if you want to look at any particular library, even though this is sessions for photovoltaic. Probably I can get back to you some other time. If I scroll down, what I'll get Simulink, Simscape, Stateflow. So you can see I have Simscape. And in Simscape, I have different sub libraries. So I have Simscape battery, Simscape driveline, Simscape electrical, Simscape fluid, foundation library, multi-body, and utility. Let me show you comparison of foundation library with respect to the Simscape electrical blocks. Now, if you are a student and you want to implement a generic system with a low fidelity, you can go to foundation library. So here you have electrical, gas, all things are there, but these are very foundational. So let's click on electrical sources. So these are the different sources I am able to see. If I go to, so I'm into fundamental library right now. Samescape foundation library or fundamental library. Under that, I'm into electrical and going for electrical sources. Okay, but if you decide to use Simscape electrical library, you have more components over here. And if you go to sources, you'll find out so many different sources are available. And here you can find out we have a solar cell that we want to use in our first example. And as soon as we try to hover mouse over here, my pointer over here, it will try to give me some explanation. Some formula is given. There are some variables in this formula. All the variables are explained over here. So this is the basic formula that is being used when we use solar cell in the Simscape electrical MATLAB ecosystem, right? And then you have over here different options available. Okay, what are other things? What are other things? You can go to, I'll show you specialized power system. You can go to specialized power system over here, and you can go to power grid elements, and you can find out I have different blocks over here. What else? Go to power electronics. I may require some bridges, half edge bridge or full edge bridge. So I have full edge bridge over here, half edge bridge over here, right? Okay. You may wish to design boost converter or buck converter. You may design this using discrete component, or I can directly use a block which is present over here. One more thing that I like to show you is with respect to the electrical machine, and then we'll move on with the demo part. If I go to electrical machines, you can find out we already have different blocks available over here. So if you're a researcher implementing complex system, you won't be using Simscape electrical to design the component from scratch. I'll be using this different blocks. Okay, so this can act as load for me, or I can have an integrated power system when I can make use of this different components over here. Okay, you can go to sources, and if you go to sources over here, You can find out I have full cell stack PV array. So someone would say, what is the difference between this PV array and the solar cell I have? So we need to look at the documentation, and then we need to understand, okay, what basically is the difference. Fine, I think this particular introduction is sufficient enough. Let us go to MATLAB. Let us go to this renewable microgrid folder. Let me click on clear comma CLC. Now see, there are different folders over here, and there is one live script. So live script is nothing but it is a combination of code, text, and images. Let me just zoom in. You can see that there are, this is version 1. Okay, you can see that there are different contents of this particular course, then you can go ahead with, right? And it requires that you should have a fundamental knowledge of different on-ramp courses. I'll be discussing about this on-ramp courses later on. These are free courses, these are self-placed, and after the session I will request you that you should go ahead and complete few of the on-ramp courses for your own understanding. I won't be completing the entire exercise, but let's look at how we can use MathWorks environment to build an application around solar PV system modeling. So there are few links over here. These are hyperlinks to different sections. I hope this formula might have been covered earlier, but still I will like to discuss upon this. So solar photovoltaic cell equation is mentioned over here, and I already talked about certain curves like power voltage curve over there. I have over here current voltage curve. Okay, and it could be expressed by the equation. Now how this equation is taken, so we have reference over here. One, you can go to MATLAB documentation, or if you scroll down, okay, it is not mentioned over here, but let me check if I mentioned somewhere. Okay, fine. This references are missing from my end, but I'll tell you that this have been taken from different papers. Anyways, what we are interested in what are these symbols. So you have I, current, voltage, then ISC is the short circuit current, K is Boltzmann constant, Q is charge, and all other parameters are mentioned over here. Okay, all the parameters are mentioned over here. I want to implement this equation. I want to implement this equation. So there are various methods, both analytical and computational, to determine the equivalent circuit parameters. Now, what one can do is one can say, okay, let me refer to the manufacturer's data sheet. Let me refer to the manufacturer's data sheet. And in that particular data sheet, some formula might have been mentioned. So in this case, let's try plotting the IV characteristics of a solar cell based upon Tata Solar Power TP300. Let us try to search what this particular keyword is all about. Okay. And I'll also share the link with you in the chat. If there are any questions, do ask me these questions. Okay. Now I have this solar data sheet with me. It can be from any particular manufacturer, doesn't matter. Okay. And then I am looking at this particular table over here. Okay. So it have different informations with respect to operating conditions, temperature coefficients, characteristics. Okay. Maximum power generation generated, electrical parameter, and so on. So if I want to take this datasheet as a classic example in my curriculum, I can refer to the datasheet. Okay. We can rearrange equation 1 over here. We'll rearrange this equation 1. And for this, we are simplifying this, assuming that V is greater than I into RS, where I is current and RS and RSH are the series and the shunt resistors respectively, as mentioned over here. Moving ahead, let us try to pull some of the parameters from the datasheet. So we have taken the short circuit current, diode saturation current, open circuit voltage, diode ideality factor, okay, elementary charge, Boltzmann constant, and I have temperature T over here, which is degree Kelvin. Now, what are this? These are my solar cell parameters. Next, I can use this equation. I can use this equation, equation number 2. So, how this equation 2 is implemented? This equation 2 is implemented in this particular line. ISC minus I0 into exponential Q into V by N into K into T minus 1. Okay, fine. What is the next thing? On x-axis, I have already mentioned the voltage 0.62. So what we are doing is we want 100 equal points, and therefore we are using this command linspace. I'll come to this again, okay, linspace. Next, we are calculating the current, we are calculating the power, and then what we want? We want IV curve and PV curve. So I have over here two plots, right? So one is plot V comma I, X label, Y label, and then I have plot V comma P, X label, Y label, and title. Let's try to run this first example. Okay, let's try to run this. So how to run this particular section? You can press Control Enter, or you can click on this blue color strip. Now before I execute this code, let me go to home. Let me click on Simulink. Okay, I will click on blank model. You have Simulink library browser over here, right? You can click on this, and then I need to search for a solar cell. Where am I going to get a solar cell? So if I go to foundational library, I go to electrical sources, right? So I'm trying to find out where exactly my solar cell is, right? Okay, electrical. And you can find out that one should have a knowledge of where exactly we are supposed to find this solar cell, right? Now let's try to get rid of this. You can double click into the canvas and you can simply type over here solar cell and see what it tells you. It tells you that it is located at Simscape electrical sources. Simscape electrical sources. Let's click on this. So this is very simple, very easy. So in script, what we are doing, we are using that formula over there. And in Simulink, we are using a block from Simscape electrical library. Hit spacebar, it will fit to the exact size of your window. If you double click on this, it has certain property, and the properties are mentioned over here, right? Parameterized by, so you have 5 parameters, 8 parameters. Next, you should enter ISC, VOC, irradiance value, quality factor N, series resistance, Then there are few things about panel configuration, temperature dependence. Okay, you can go to description. Right now there is nothing over here, but you can see that we are trying to use the same formula as it is mentioned over there. I'm not going into this formula. I'll go to settings. What I'm interested in, either I could enter the same values over here, assign the same values over here, or I can click on this, click to select. So someone can say, if I have values which are being taken from the manufacturer's data sheet, okay, why can't we pull the values of manufacturer data sheet here itself? So you can click on this, click to select. A new window pops up. Okay, we are just waiting for this block parameterization manager over here. Let's wait. Okay, I have this. And now I can select the parameter with respect to the manufacturer. So you can see I have different manufacturers over here. So click on Tata Solar Power. Let us suppose Tata Power Solar. Okay. Then you have different part numbers, TP300 for example. Choose this. It tells you collection ID, part number, where you'll find the data sheet. It gives you part type 300 watt, polycrystalline, VOC, ISC, VMIM, and so other sort of things, right? And then additional parameters are mentioned at the bottom. You can uncheck and check the different parameters that you want, and you can simply click on apply all, right? If you do this, and now if you go to your environment, that is your model, can you see over here it mentions Tata Power Solar TP300. Dear participants, any question at this particular moment? Please let me know, because this is important stuff that I wanted to cover initially. Okay, I hope everything seems to be fine at the moment. Okay, so I'll be taking a demo where I'll be taking a generic components. But what you are supposed to do is you are supposed to click on this, and you can choose different manufacturer
वो लोग चले गए क्या?
parameters from here. Let me
पीने
close
वाले
this.
हैं वो ऊपर डिस्ट्रिक्ट हॉस्पिटल है, हो भी सकता है। नहीं, वैसे
Now,
पीने वाले हैं वो। हाँ, तो वो अपनी व्यवस्था कर रहे होंगे।
now what do
ये
I
डिस्ट्रिक्ट
have?
हॉस्पिटल
I
ये
have
ऊपर है
over
जो
here.
Pankaj, please, sorry to disturb you. Pankaj, please, you can
मेडिकल कॉलेज
mute
नहीं है
your
ना
mic.
मॉडर्न? अच्छा है तो यार भाई फिर काम
Pankaj,
कर। वो आगे शिखर होटल है, यहाँ सामने, यहाँ वो पोल दिख रहा।
Can I continue, sir?
yes, you can.
Yeah. Thank you, sir. Okay, so I think I have made this point clear that if you're using script, you need to implement this particular formula. This is a simplification of the actual formula. You can enter the values, okay, and later on you can use this particular code just to plot the graph. So how to run this particular section? You can press Control Enter and you can click on this blue line, blue bar over here, I could say, to execute this section. And one more thing that I want you to focus upon is, see the entire text where there are no numbers on the left hand side. This is text, these are comments, right? And whenever you have this numbers 1, 2, 3, 4, 5, 6, 7 under this gray color part, this represent code. So let's click on this. What I'm expecting at the output is that I should get IV curve and PV curve. Okay. Let me zoom in. I'll show you one more thing. So I have current, I have voltage, I have power. I have opened this figure into figure window. Now, if you know this, you have things like tools, and you have something is known as basic fitting or data statistics. You can go to basic fitting. May not be relevant for the first time user, okay? But if someone wants to fit this curve, the basic idea is like I can use a basic fitting tool. You can see there are different options over here, and later on you can get tables, which is fitness of curve. Okay, what is next? You can go to format, figure, and you have an option over here where I have this text arrows. So I can use this text arrow and I can indicate, let us suppose I want to draw some arrow over here and I want to indicate, okay, what is this? I could say voltage is max, current is minimum. Okay, so I can say minimum I or I minimum over here. Let us suppose. Similarly, I can indicate, okay, this is the max power that I've got. So I can keep on adding the arrow. I can zoom in, or I can click on this home to restore the view. And later on, when you click on this save as, you can save the entire figure. Okay. And then whatever annotations you do, you have an option over here to show the code. So whatever code you have written over here while annotating this, like I have added I minimum, you can see over here that for this particular dot, we have this annotation text arrow. This automatically gets added. I can copy the code and I can get back this into my actual script to regenerate all the annotations. I hope I have made you understand. If I want to copy this, you can quickly click on copy as an image or save as a file. I can go to my script and you can see, let me click on text part over here and I should be able to copy the figure. So this is the figure that I was talking about that I have copied from there. And you can see there's an annotation over here. Select, delete it. Any challenges, anything you want to ask? I know like you all might want to use Simulink and Simscape for this, but still any challenge? Any question?
Participant, if you have any question, you can unmute your mic and ask the question.
Fine. Let me move ahead and let me explain you that how we can implement this equation, okay, with respect to equivalent circuit model. Now, most of us might be thinking that, okay, we have implemented an equation over here, line number 9. This is an implementation of equation. We have assigned the value. But can we go for an equivalent circuit model over here? Yes, we can go for an equivalent circuit model over here. And how we can do this is, so we have already created a model named equivalent circuit solar cell dot slx. So whenever we go to Simulink, for example, this is my Simulink model, I need to go to save, and if I click on save as, by default the extension will be .slx. So .slx over here indicates that it is a Simulink model. So I'll say my solar cell, and by default it will take save as type Simulink model. Do not try to type .slx. Keep it as it is. Click on save. I have saved the model. Later on, I can go to classroom, or if I am presenting in front of any other person, There's no need for me to evaluate or run the model every time. I can save all the parameters and this particular model itself. The model is saved. Now I'll close this. So if you go to your directory, let me expand this particular section, solar PV. You will find it over here. Already a file has been added, which is Simulink file name equivalent circuit solar cell.slx. One way to open this file is to right click and click on open, or you can directly call it from MATLAB script by calling the model name. So model name is equal to the file name, and then we can go for simulate model. This particular instructions from line number 22, 23, 24 will open the model and simulate the model. Let's look at this. Let me get rid of the irrelevant windows that are open over here. And let's wait for some time. So it is trying to launch this particular model right now. Let me close this template. Okay. What I'll do is it's still taking some time. Let me close this. There are a lot of windows that actually opened over here. What I'll do is I'll open this particular model from here itself. So either we can launch the model from here or from this thing itself. Okay. What if I want to build up this model by ourselves? How exactly can we model this? I'll also show you that. But first, let us try to simulate the model which we have. Okay, this is our model. And this is the equation. So if you look at this block, this is current source. I have irradiance value over here. Okay, this is a gain block. I'll show you if I, not the entire thing, but yes, few of the blocks. So I can go to blank model. This is my blank model over here. If I go to this model and I need the formula, Control C, and you can directly copy the equation. If you have equation in the latex format, you can also enter the equations. I'll just try to increase the font. Next, see, I need irradiance. So for this, what I'm going to do is double click. I'm going to use constant block. I will use this constant block. And what I can do is I can assign some value over here. So double click, you may assign some value. So let this be 1000. Apply and OK. Now if I look at this formula over here, okay, I need this ISC by IR0. How am I going to get that? If ISC and IR0 are not going to change over here, then they represent a constant term. And in that case, what I can do is I'll double click and I'll take a gain block. So this is a gain block over here. Okay. Let us try to connect these two blocks together. Next, I need a current source. So this is my current source. So from where I am going to get this? And what kind of current source is this? You can go to Simulink library browser and search for the current source. So there are two options. One would be Simscape Foundation Library. You have electrical sense, okay, electrical sources, and you can see there are different sources over here, right? Okay, or you can go to Simscape Electrical Library, and you can go for sources over here. Now depends upon you what particular source you want. Okay, if I look at this example, this has to be current control source. So I will go to the foundation library, and you can see I have this option: control current source, control voltage source. So what is this? Control current source. What I can do is I can drag and drop this. So you can resize this window. This is our Simulink model that we are designing. Okay. What you can do is either you can double click in this canvas, the empty space over here, double click and search for the component, or you can drag and drop. You can see I've been able to drag this current control source. Similarly, we can keep on adding all the elements like this. So this is diode, this is control current source, series resistance, shunt resistance. I will require sensors over here. So I have current sensor, I have voltage sensor. This is for current load, we could say. Here, this is ramp signal. This is the ramp signal over here, which is indicating a slight increase. So we know this formula: unit step is A equal to 1 for t greater than 0, equal to 0 for t is less than 0. What is ramp? It is written as A into t. So if A is 1, it becomes unit ramp. So as a time step increases, its value will also keep on increasing. One more thing that I like to highlight, focus upon, is the solver block. This solver block is really, really important for us when we are simulating the physical model. Now you might be able to see the difference. The difference is few of the blocks are in black color over here. This represents blue color. Then we have brown color over here. What exactly this is indicating? See, all the black color blocks which you see over here are Simulink blocks. Okay, the blue color one are representing Simscape blocks. Simscape. When you look at this brown bus over here, this brown bus and this buses over here, they are indicating the interface between Simulink and Simscape. So when I had launched the Simscape template, you might have observed over here there are utilities. Under electrical, you go to this and then you will find out its utilities. Or I'll show you, double click. You have Simulink to PS converter, physical. And similarly, you have PS to Simulink converter. So this thing act as an interface between Simulink block and Simscape block. Let's go to this model. I want to simulate it. You can keep the start time and the stop time over here. And as indicated, every block have associated with some of the formula over here. So we need to double click on the components and we need to check what are the values that we can assign over there. Defer the values. I can give RS value, RSH value, and so on. This is ramp. So slope is 1, right, as I indicated, and initial output is -3. Fine. Okay, these are current sources and voltage sources. Double click on scope and let's try to run the model. So to run the model, you can click on this green button, run. Okay, and at the bottom, you can notice running. Okay, can someone help me in understanding what is this graph about? Anyone? Okay, fine. No issues. No issues. Okay. At least we understood that how to build up the electrical equivalent circuit of the photovoltaic cell, right? And we've been able to measure current and voltage. Now, someone would say, if I want to measure power, so what we can do is we can have a multiplication of these two values, and I can take another block over here. So I can go with A and D, and okay, or I can go with multiplier MUL. And then what I can do is I can go with product also. Now I have shown you all those things. If you have binary values, you can go with A and D. Okay. Most preferable we'll find out we will use this product term if you want to multiply it. So I can take over here current and I can take over here voltage. I'll get product of voltage and current over here. In this case, what I can do is I can take a display block. If I want to understand only the value, I will use this. So now you might be able to understand that how easy it is to build up or create a model in the Simulink environment. Let me close this. And now we will directly use the solar cell instead of using this. Okay. Any comments on the curve, whatever results we got? You can enter that into chat box also. I'll be happy if any one of you could answer them. Sir, at what time we should finish? Like 9:10? Hello?
Sir, by 9 o'clock.
9 o'clock. Okay. Then, sir, I have less time. I'll try to see how much I could accommodate. Okay.
Okay,
Fine.
sir.
Fine. Okay. Now, this is an example where you can say it is similar. It is exactly similar to what has been done earlier. But here I have used different irradiance levels, 200, 500, 1000 at temperature values. This is a shipped example from MATLAB documentation. I'll be sharing this link with you. So those who want to use the trial license of the MATLAB or already have MATLAB with them, you can click on copy command over here. You can go to MATLAB and in the command window, you could type, copy paste this command. Let me click on clear comma CLC. Okay, to get rid of the earlier variables, you can control V and enter and you will get that particular example. I have already downloaded and saved this example. So it's very simple. I will directly launch this solar cell power curve.xls model, and it's very, very, very simple. I think I have already shown you how to drag and drop the solar cell and how to use the battery parameter over there. So it's very simple, right? This is solar cell, if you remember. I've already shown you. Over here, I have, inside this, I have current source. This is current sensor. Okay, this is current sensor. Over here, what do we have? We have control voltage source. This is the test voltage. Over here, I have FX solver. From here, I am getting voltage. Here, I have get current. This is the product. So what we can do is, and we have irradiance level. Now, instead of directly applying the values in the Simulink block, it is a regular practice that we try to ensure that all the values are written in the script. So at the background, you will find out I have script over here, and I have all the parameters. So I have a command over here, if you can see. Set underscore parameter, find solar cell, find all the things. Okay, I have this. And there is one more file over here. And what this file is talking about, it's talking about the irradiance vector. 3 different values. Temperature vector, 2 different values. This is the name of my system. Right? Now, I will require one particular object to hold the power values, whatever gets multiplied, right? 220, 500, whatever. So so this is a matrix over here with the values. And then for all the irradiance and temperature values, we will try to simulate the model and log all the data. And later on we will generate the plot. This is very simple. So I am repeating this again. Specify irradiance vector and temperature. Next, open the model. Okay, simulate the model. So I have this for temperature is equal to temperature vector. So this loop is supposed to run for 2 times because I have values 20 and 40. But inside this, if I have called irradiance, so you can see for irradiance equal to irradiance vector. So this loop, inside loop also has to run. Accordingly, at the end, I will get all the results, and all the results are logged into this particular vector. Later, we'll try to plot this curve. Then what we'll try to do is we will try to find out the max value so that we can get P max and ID max. Okay, this is nothing but determine the optical operating point as function of irradiance and temperature. So how we can do that? You should go to MATLAB and first check if there are any variables over here. Yes, I can see irradiance and temperature over here. But these are with respect to the earlier example. You can see the value 1025. And that's the reason, we should type clear and CLC. If it is there in the file, it's fine. If not, then we'll try to manually do this. If you want to run the file section by section, I've already told you, control enter. Let me click on run button so that I should be able to simulate the model. At the bottom, you can see what are activities going on at the background that is being mentioned. So this is a common question that comes from user, that when you try to model a system and whatever results are generated, what are the different ways that result could be saved? Okay, what are the different ways that result could be saved or exported to an Excel sheet, which later on can be used by us? So this example shows us the similar thing. You can double click on scope. And for different irritants level, different irritants value and temperature value, we have been able to generate the curves. Any question, anything you have over here? What experiment we can do now is, we can use the same model. Click on this, double click on the solar cell, and over here you can use a particular battery from a particular, sorry, not battery, particular data sheet from the manufacturer. Now, if I want to take a battery component over here, okay, I'll get the same option. That's the reason, I um, mentioned battery over here. Okay, now there are many such components. Even for motor, you can take the data sheet from here, manufacturer data sheet. For solar panel, for batteries, for different components, you can directly use the manufacturer data sheet from here. Okay, I do have 5 minutes more, so I'll move to the next example. You can look at the key results and insights like higher returns, what exactly it does, and so on. There is one more example over here wherein it actually talks about parameterization and validation. Let me give you just an overview of it, and then I can ask Ankit to cover rest of the things. Again, this particular example is over here. I am sharing this link with you. Now, these are the stepping stone of moving towards PV modeling, PV solar modeling. Okay, fine. Let me close the earlier windows and the earlier files. And let me clear NCLC. What I can do is, I can add in shortcut over here. I can customize my MATLAB toolstep, and I can add and clear CLC here itself somewhere, so that I don't have to do it again. But usually I don't do this because it makes me understand that if there is something in the workspace, then I need to clear everything first. I'll just walk through this example due to the timing constraint. But yes, what this particular example talks about. So this example shows how to model a solar panel by using the data from a manufacturer data sheet. Okay. Then we can use this entire datasheet data to generate the current voltage and power voltage curve for the solar panel. And then this will help us to identify the peak power for a given irradiance level and the panel cell temperature. And then you can see like why we are doing this. As mentioned earlier, this peak power is then useful when designing an inverter. This is a very simple example. The input is irradiance over here. At the center, we have solar panel. We have different sensors to measure the current and voltage. Over here, we have test voltage. Now, this is the basic building block. Right? Okay. So, when we talk about the solar panel subsystem over here, it basically contains parallel connected string of series connected solar cell. What basically it has few variables like NP cells and NP NS cells, number of parallel strings and number of series connected cell in each string respectively. It will look something like this. So there are some assumptions. What assumptions we are doing is that all of the solar cell connected are identical and temperature and irradiance levels are same for each cell. Fine. Now, let me just show you the script for this, like how we have used different parameters over here. You can look at these files, and if you go through this, it gives you a complete instruction. Now, this is a file where you open the model, set the parameter, okay, display the model, and later on look at the results. There are other files also where our data is present, that is solar panel validation input.m. Okay, if I double click this file, you will find out that we have taken some parameters from the datasheet itself. I have shown you that how you can use Simulink model for the same. Can you see I have all the parameters? NS cell, NP cell. Okay. Later on, what do I have? I have over here this temperature coefficients. Units 1 per degree Celsius, measurement temperature, irradiance level, and then there may be some non-datasheet parameters that have not been defined into the datasheet. Okay, so basically this could be NQ value for diode dark current. Then you have series resistance. Okay, and then you have temperature exponents for diode saturation IS and some temperature values. So this may not be defined and therefore we are defining it. Let's run this. Fine. Okay. Next, let's launch the model. So this is very simple. You have irradiance. I can use slider over here. We don't have that time today, but we can use slider over here and I can do this in runtime itself. If you look at this subsystem and if you try to double click, see what it tells you: block parameter solar panel. Okay. Models a solar panel using parallel connected string of solar cell. The solar cell string are modeled using single solar cell block. This is a mass subsystem, and over here I'll find out that there is one arrow. So if I click on this arrow, I'll get the internal structure of this subsystem. Okay, so again you have current control source over here. You have solar cell, this input port and output port. So 2 and 3 can be output, 1 is input, and I have IR, which is irradiance over here. Okay, and test voltage. Let's try to simulate the model. So now here what we are doing, we are mentioning the parameters in the script. We are launching the model from the script, and then what we are doing is, even for plotting, we need to understand what are we going to plot. So for that, what we need to do is number of plot. So depending upon the irradiance and the temperature vector, I can check the product and I can go for the length. So if this comes out to me, in our case, I have 2 temperature values and 3 irradiance values. So I need to understand how many number of plots will be there. Okay. Do I need to use some color map? I'll use the color map. Later on, we will have some objects. Now all these are 0 at present because there is nothing into that. When you simulate it, again you have 2 for loops. Temperature 20, what happens inside? Everything will be logged. Same is the case for different temperature and irradiance value. And then later on, what we'll try to do is we'll try to plot the graph. Again, we'll try to find out the max uh, power operating point over here, and we'll display that in the graph itself. And you can see over here now, what is the stop time? Stop time is 1.1 multiplied by VOC by 1. You can change the stop time as per your requirement, 10 second, 20 second, on depending upon some condition that the voltage have reached this point. It should not go above this point, or depending upon you, how you want to take this ahead. And now you might be able to see that I've been able to generate one figure which actually points out to how I can validate a solar panel. So by the time this figure is being generated, any question from user, participants? Okay, if you look at this graph, what we are able to understand, what are the best output voltage and or where exactly I'm getting the max output power. Can I assume this particular point is the one which I will be getting maximum power? So I think, sir, that's all from my side. Uh, so there are a few courses which I want the participants to complete. MATLAB on ramp, it will help you build strong fundamentals for scripting. Later on, Simulink on ramp. These are freely available courses. Circuit simulation on ramp for power electronics and other things. Okay. And the last one, which is really important for us, is power system simulation on ramp. So here, this is a small example of a microgrid over here. You can say solar, you can say DJ sets, you can see main grid and all other things over here. So that's all from my side, and thank you. If there are any questions, I'll be happy to answer them.
Sir, on last graph,
Hmm.
which temperature you have considered?
Okay, let me go to the script. So if I go to this, sir, solar panel validation input, this is my file, and in this file we can find out at the bottom the temperature values are defined.
Okay.
What I'm saying is, like, there is no need for me to have temperature over here in this particular way. I could have used slider over here. We don't have that much time now, but what I can do is I can use slider over here like this.
Okay.
I could have used the constant, and I can here itself would have varied. So in the
Okay.
real time, I will be able to see the effect, how the graph is reaching to the maximum point and other thing.
Okay. Same you can do for irradiance also.
Yes, yes. Basically, that is what exactly we want to do. We want to
Okay.
minimize the thing, and the most important thing is we should use a battery manufacturer datasheet here itself.
Okay. And normally we have to see temperature between 25 to 50. Like.
Depends upon manufacturer, sir, and the like where exactly we are going to place the solar cells. From manufacturer to manufacturer, it will be different.
Okay.
Basically,
Thank
we
you.
should focus more on number of cells in series
Okay.
and parallel.
Thank you.
Thank you, sir.
So, any more questions?
Okay. Before I conclude, just wanted to understand, do you want the link for that modular curriculum? Any participants?
Yes, sir. Please send.
Yeah. So, sir, I'll be sharing it with the coordinators for this event, and they
Okay.
will share you the link where I would share today's demos also.
Okay, sir.
Okay. Okay. Thank you.
There
So
is
now,
one question in chat box.
Just
The question is, sir, can we add this math work in the photovoltaic system and Homer professional software?
didn't understood like what you want to. You want to integrate.
Yes,
Yeah. So you are talking about console.
Homer professional software.
So, sir, what we can do is like, okay, this is a good question that you have raised. See, sir, like most of the time user asks this, like if MATLAB can be connected to other tools also. So you can go to home, you can click on add-ons, the window gets launched, and then we need to find out if there is a plugin. Like for console, I know that there is a plugin where I could share the data between MATLAB and console together. For the tool which you are mentioning, I need to check on that, sir. But anyways, I'm showing you the procedure how you can do it. So once you have launched your tool, you can go to add-on, and over here I can have console, for example, COMSOL. So if I have this, I can see like does it supports different tools? Yes. So these are different add-ons. If you're looking for any other tool, we need to just search for the tool over here and we can get it. One more thing that nobody asked, but since we have raised this question, just like to tell you that if you go to this demo files, sir, I hope I'm not buying much time. If you go to this particular script, I'll ask Ankit also to show you this tomorrow. Okay, I'll discuss with him. So you have this solar pv.mlx file over here, and over here the MPPT algorithm is implemented. If I can zoom in, let me zoom in the file. I hope you are able to see this graph. MPPT implementation using state flow. So Ankit will cover this definitely. I didn't got time to do this. So someone can say, okay, Kunal, everything is fine, but if you have implemented this MPPT using state flow, will I be able to generate this as a C code and deploy it on hardware? Yes, that is possible. Now for this, I don't have to be like a person who knows MATLAB programming or person who knows C programming. You can simply design this logic in Stateflow, right click, you have an option, generate C code, generate the C code and deploy it on the hardware. So this is with respect to the algorithm point. So if you go for MPPT algorithm, if you go for batteries, BMS algorithm, battery management system, you'll definitely find out that in industry people try to use state flow because it is easy to understand and it actually shows you what are the states it's actually active in right now.
So that is sir done.
I am sharing my email ID, sir, in the chat. If anyone wants to reach out to me, you can reach out. Thank you, all the participants. I hope I have not taken your much time. And
It
thank
was
you, sir,
fine,
for
sir.
giving me
No
this
problem.
opportunity.
So it is the time to say thanks to sir on behalf of management principal and Atal FDP organizing team of AC Patil College of Engineering. I express my deepest gratitude towards Kunal Kandelwal sir. His talk must have exposed you to wealth of hopes of possibilities of utility of MATLAB for doing research in the area of solar cell in the coming session. So it was wonderful, sir. Thank you very much.
Thank you, sir. I hope I have been able to add some knowledge to the participants. And thank you very much.
Thank you, sir. Thank you very much. Good night.
Thank you. So,
Thank you,
may I
sir.
sign out now, sir?
Yes, sir.
Yeah. Thank you, sir. Have a good
Thank you.
day.
Thank you.
Bye.
Thank you.
Bye, sir.
Thank you,
Thank you,
sir.
participants. Yeah. Thank you, sir.